Welcome to this explainer. I am absolutely thrilled to have you here today, because we're going on a journey that's, well, entirely invisible to most of us. Just picture this for a second. You step into an elevator right in the middle of a bustling Indian metropolis. But instead of going up to a shiny new skyscraper, we're going down. We're taking a ride straight down through the hidden, chaotic, and honestly fascinating layers of India's urban infrastructure. So, as our imaginary elevator starts to descend, I want to hook you right away with this exact question. Who governs the city below? Think about it. We experience the surface every single day, right? We walk on the sidewalks, we wait at the traffic lights, we see the zoning of buildings. But a massive, essentially ungoverned world exists right beneath our feet. And as we're about to see, ignoring this subterranean world has some pretty profound consequences. All right, let's kick things off with Layer 1, the unseen urban crisis. Okay, let's really dive into this. Our descent begins just below street level, in the shallow underground. And right here, we're seeing this startling juxtaposition in cities all across India. On one hand, we're building absolute modern engineering marvels deep underground, like massive, high-tech metro tunnels that seriously rival anything else in the world. But then, right next to them, or literally just above them, our basic utilities are failing catastrophically. It's like we're trying to build 21st century infrastructure inside a 19th century administrative blind spot.
And the human cost here is very, very real. In Indore, a sewage line contaminated a drinking water pipeline that was running right beneath a residential neighborhood, and tragically, that killed at least 10 people. In Delhi, the newly built Pragati Maidan tunnel floods constantly during monsoons, completely bringing traffic to a dead halt. And across the country, sanitation workers are routinely losing their lives to toxic gases and sewers. Now, these incidents are often brushed off as just local contractor errors, but experts are warning us that this is actually a massive systemic failure. Tunnels and basements are being built completely blind, directly overlapping and intersecting natural drainage paths, without anyone really looking at the whole puzzle.
Moving down now. Layer 2. Who governs the underground? As we peel back the Earth to this second layer, we hit a complete governance vacuum. When we ask who's actually in charge down here, the answer is, terrifyingly, pretty much no one. And this brilliantly illustrates the contrast. Just look at the surface. Our world up there is heavily regulated. Strict land use zoning, building height limits, rigorous environmental clearances, the whole shebang. But underground? Total Wild West. There's no national policy on underground space, no comprehensive binding safety codes across all utilities. Instead, you've got metro corporations, road agencies, municipal water boards, and private telecom companies all digging in their own isolated silos. They're just granting their own permissions without assessing the cumulative risk of what everyone else is doing.
This quote from architect Manit Rastogi really hits the nail on the head. He says, authorities are relying on quick, reactionary engineering fixes, constantly patching up and waterproofing flooded tunnels, instead of stepping back and creating a unified, three-dimensional underground master plan. Actually, scratch that. It's worse. We are quite literally planning our modern cities on a flat piece of paper.
All right, going deeper. Layer 3. India's massive tunneling boom. Descending into the third layer, what's truly astonishing is that despite this complete lack of overarching rules, an incredible amount of engineering is happening right now in the dark. Take a second to process this massive number. 3,500 kilometers. That is the total length of tunnels currently under implementation across India. To put that into perspective, that's roughly the driving distance from the northernmost tip of Kashmir all the way down to Kanyakumari. It's a subterranean boom of epic proportions.
Now, what's really interesting about this slide is who is actually doing all this digging. You might immediately think of urban metros or road tunnels, right? But irrigation actually holds the largest share of the pie. That's followed pretty closely by complex hydropower tunnels and massive railway projects just carving their way through the insane terrains of the Himalayas and the Northeast.
Let's ground all this abstract data with a concrete case study, just to understand the sheer scale of what's happening. Take the Mumbai Metro Line 3, the Aqua Line. This is India's first fully underground metro system, spanning 33.5 kilometers. To pull this off, the project required deploying 17 massive tunnel boring machines, TBMs, just churning through the earth beneath one of the most densely populated cities on the entire planet.
And the challenges they faced, absolutely awe-inspiring. Especially this 170-meter section running directly beneath the Mithi River, right on the partition between Dharavi and the Bandra Kurla complex. We're talking about digging 15 to 20 meters below the surface, and the geology here isn't just neat, solid rock. It's totally unpredictable, weathered, brecciated basalt, basically highly fractured and broken volcanic rock. The engineering risk is off the charts because you have high fluid pressure from the river and muddy swamps above, constantly threatening to rush in and just flood the entire tunnel.
So the crucial point is, how do engineers actually survive and build in these conditions? Well, when they need to build complex cross-sections or third lines for parking trains, places where those massive tunnel boring machines just can't physically maneuver, they use something called the New Austrian Tunneling Method, or NATM. And rather than just brute forcing their way through, NATM is this incredibly clever philosophy that actually uses the strength of the surrounding soil and rock to support the tunnel itself. It's a highly meticulous, almost surgical process that happens in 3 distinct steps. First is the heading, where they carefully excavate just the top curve of the tunnel. Second is the benching, taking out the center. And finally, the invert, which is excavating the floor. As they inch forward, they immediately secure the exposed rock by spraying it with concrete. This is called shotcreting. It lets engineers literally feel the ground and watch how it behaves, step by slow step, completely in the dark.
Now, for the main tunnels driving directly under the riverbed, they rely on specialized earth pressure balance tunnel boring machines. And these technological beasts do something mind-blowing. They monitor and adjust the pressure inside the cutter head to perfectly match and balance the massive fluid pressure coming from the river outside. So they seal the water out, while a mechanical arm right behind the cutter head constantly lays down precast concrete segments to form permanent rings. Any tiny gap left behind, instantly filled with grout. They are practically building a completely sealed submarine tube while actively chewing through solid rock. No way around it? That's just incredible.
Let's move to our final bedrock layer. Layer 4, Master Planning the Deep Future.
So, what does this all mean for us? How do we actually master plan our 3D future? We've seen the absolute chaos of the shallow underground and the brilliant engineering of the deep underground. To find a governance answer, we have to look at global benchmarks. Way back in 2010, Helsinki approved a comprehensive 3D underground master plan mapping its entire municipality. In 2019, Singapore officially zoned specific underground depths for utilities and data centers, legally recognizing the underground as a finite urban asset to free up surface land. In contrast, while India launched the AMROOT 2.0 urban mission in 2021, its focus still heavily remains on mapping and upgrading surface infrastructure. Honestly, our legacy cities are lagging far behind in recognizing this third dimension.
But we do have a localized blueprint for success right here in India, at Gujarat's Greenfield Gift City. They eliminated that fragmented silo digging altogether by constructing a massive shared multi-utility tunnel. We're talking 16 kilometers long and large enough for a literal maintenance vehicle to drive right through it. It houses power, water, sewage, telecom, all monitored by a central SCADA system, which is essentially a high-tech digital brain providing real-time control. And the biggest benefit? The surface operates flawlessly without that constant, destructive, hair-pulling nightmare of your commute being dug up every few weeks for random repairs.
Now, Gift City was built from scratch. For legacy cities like Delhi, Mumbai, or Bangalore, we obviously can't just build a giant utility tunnel overnight. But as architect Dikshu Kukraija points out, the absolute first priority isn't just digging more holes, it's comprehensive subsurface mapping and data integration. Before we can even hope to govern, we must mandate a shared 3D database of what is already buried down there. Without mapping those overlapping water lines, power grids, and metro tunnels, any new regulations are going to remain completely superficial. So, as our elevator finally returns to the surface, I want to leave you with this to ponder. The next time you walk down the street or drive through an underpass, take a second to think about the invisible, chaotic 3D world operating right under your feet. Is the ground beneath your daily commute a carefully mapped foundation for the future? Or is the lack of planning a disaster just waiting to happen? Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I will see you next time.